All right, so I want to start with an introduction to the workshop I've done twice at DEF CON. Summarizes what's going on here, so you know who I am. And this, I think, is real important. This is Gartner's hype cycle for artificial intelligence. And if you're not familiar with it, Gartner is a company that makes predictions about technical future. Their whole point is people pay a lot of money for their reports, and their reports tell you about all the current trends in technology, and they predict how much they expect them to change in the future, so you can make investment decisions, you can decide what technologies to develop within your corporations and things like that. And so artificial intelligence, there are many, many types of artificial intelligence. And notice that generative AI is right here at the peak. Now this is called the Gartner hype cycle, and their idea is first something is new and nobody even knows what it is. This is innovation. And so for a while it rises and people don't even know about it. Then you reach this period of time when it is the new hot thing and it's going to save everybody and change the world, and there are inflated expectations. Everyone expects it to just go, go, go. And this applies to everything. Autonomous cars, the internet, everything you can think of goes through this. There's a period when everybody thinks this is the new fantastic thing that's going to make us all rich and change everything. Then you begin to notice that there are problems with it, there are limitations, it's not quite as good as it should have been, and then people get really mad at it, and there's the trough of disillusion when they say, this stuff is garbage, don't even talk to me about it, I'm going to disband the team working on it, I'm going to fire everybody that says that word to me, like blockchains, I think, are down here now. For a couple of years ago, blockchains and cryptocurrency were going to change the world, and now everybody's pretty mad at them. And then, after you're done with all this nonsense, you hit somewhere in the middle, where, okay, it's not saving the whole world, but it does have some value, and it's just another thing like cars or spreadsheets or televisions that are just part of our world. That's when you're out in the plateau of productivity. Then you finally figure out what it is good for, and you use it for that. And they say, for example, computer vision is all the way over here. We've kind of gone through all the nonsense about computer vision. There was a time when the police were using it to identify criminals and convicting the wrong person and all that. And now it's just kind of become common. It's everywhere. It's all around us. But other things are here. If you look, so generative AI is at the peak of inflated expectations. Everybody is using these large language models for everything and trying to convince you that you can fire your staff and replace them with an LLM. And people are just beginning to notice that that's not really true. They're beginning to notice these things are really expensive to run, and they don't actually work terribly well. And so we're about to go through disillusion as people get really fed up with these large language models and think they're worthless, and eventually we'll realize they're just another thing to help you. You see many things here like smart robots. The thing I think also is really important is this one, AGI, Artificial General Intelligence. The people in Silicon Valley, like Sam Altman, have been telling everyone we are going to have AGI within like 1 or 2 years. They mean we're going to have a machine that is as smart as a human. And then you can really replace your staff with AI. And they predict that's coming any day now. And they even claim superintelligence, something much smarter than humans, is only like a few years off. And I'm really glad to see Gartner do this. The triangle of Gartner means no progress at all in 10 years. As far out as they can see, this is garbage. This is not going to happen. I was real glad to see this because I've been saying this for years. And you're going to see that in this course. If you understand how AI works, you're going to realize how far it is from being a human. It's got some value. It can help you, but it is not going to replace a human, not anytime soon. They are just crazy. In order to attract investors, they are just wildly exaggerating its accomplishments. And a whole lot of gullible people, unfortunately a lot of our federal government officials, are believing this garbage, and they're afraid that it's going to turn into the Terminator and wipe us out. And none of that is going to happen. And we'll see why. And I'm glad to see an authoritative source like Gartner agrees with me on that. Anyway, so there are various types of machine learning out there. The simplest case is supervised learning, where you have some labeled data like you have emails, and humans have looked at it and decided that some of them are spam and some of them are good email, so you practice until you learn how to tell one category from the other. That is a relatively simple task, and but it's interesting to know how it works. Now, unfortunately, you often don't have labeled data. You don't want to pay a human to label it. So, for example, if you want to train a computer vision model, you can go on the internet, like Instagram and everything, and download a bunch of pictures, but you just have a bunch of pictures. They're not labeled, so how do you train from it? Well, you can still do things. If you have a bunch of data that's not labeled, you can do things like sort it into categories. And this is useful. If you have customers that are buying things at your shopping site, you can see what they buy, and they might separate into groups. Some of them buy these products, some of them buy those products, and just separating the groups might give you the ability to predict what to offer them next, what other sorts of things similar people buy, and that sort of thing. So you can do something even with unlabeled data. For example, anomaly detection. If you want to find the fraudulent credit card transactions among all the credit card transactions, you can find the ones that just seem to be strange. They are a strange amount, they come from a strange country, they're done at a strange time of day, something like that. That's anomaly detection. Or find the products on a machine, assembly line that are defective because they're too big, because two of them are stuck together or something. So, and then the other thing you can do, which is super powerful, and this is how all the large language models are made, and we'll go through quite a bit of this in the projects. You can make labeled data out of unlabeled data. So you download a picture of a kitten, and then you cover up part of it. And now your model tries to fill in the missing part of the image. Now you know what the right answer is. So you give it this and say fill in the missing gap, and then you measure as it attempts to do that how close it is to the right answer, and you can now train it. This is a very good way, and this is how large language models learn. You start with sentences written by humans. You find just a database like Twitter or Wikipedia or something that has a whole lot of sentences written by humans. And then you mask part of them. So you have a sentence like this: artificial intelligence, mask, take over the world. And now your large language model learns what word would be appropriate here in context. And BERT, which is one of the pre-trained models out there, says, well, 32% probability that word is can, 18% it's will, 6% it's to, and so on. So there are various sentences here that it's created, and because it's practiced on a whole lot of other English sentences, it's able to deduce what should be put in there. And that's how you use a large corpus of unlabeled data to train large language models to write English. So then we can talk about securing these systems, which is a real problem. They're turning out to be far more insecure than people thought and far more difficult to make secure than people thought. So there are some helpful guidelines out there. The National Institute of Standards, the U.S. government has put out a risk management framework for AI. Unfortunately, they focus on these large national threats, but they're kind of right, harm to civil liberties and such, because the AIs tend to be bigoted racially. Harm against discrimination and so on. That's certainly true. Harm to your business operations and your reputation from using an AI. This has already happened. There are companies that have deployed AI bots and then gotten a bad reputation from it because they did terrible things. And of course, harm to the ecosystem or the global financial system and stuff. So they're right that all these things could happen, but usually those things are much bigger than an individual company. So in things like my students are doing and my consulting work, I'm not really trying to save the whole nation. We're trying to help one company decide what to do with their corporate AI policy. And this level of this standard is a little bit too high and broad for them. But this is an interesting document to help guide you in the structure here. You can have how interpretable is a model, how well do you understand how it works, and how powerful is the model. Now, the simplest models are like linear regressions or decision trees. These just draw a straight line through some points, or they just have a series of if-then statements. And so it's very easy to understand how they work, but they're not very powerful. The large language models are deep neural networks, a whole layer of neurons, each contributing millions of neurons connected to other millions of neurons that process the data. So they're very powerful. The problem is, if they do things that are wrong, we don't know how to fix them. We don't know how to secure them. Large language models will do certain things wrong, like they will just make up false statements and present them as true, because the only thing the large language model knows is how to make the text look good. They know how to make the sentences smooth and how to make the paragraphs fit together, but they don't actually have any clue about what the truth is or what a lie is. They just make good-looking pages without actually connecting to the facts. So they frequently hallucinate, make up completely false things, and then make a really convincing, professional-looking document presenting that. And we would like to stop that, but we don't know how, because it isn't like it's got Python code, and there's a line of code that we could tell it to do something else and it would obey it. It's just learned to write English. Millions of neurons have been adjusted to a certain weight that causes it to write English. And if you change some of those weights, we don't really understand what it would do. So we are not in very good control of it. And there's all these ones in the middle. And we'll talk about these as we do them in the projects. And then there's the new one, CANs, which are a network which is hoped to have almost as powerful as a deep neural network, but much easier to understand and control. And that's hopeful. but they're in early stages yet. And we'll set up all these in the project. You'll get to see what they do. So the British National Cybersecurity Center has posted their standards, which I find much more at a practical level. So when you think about your AI project at your company, decide what you want to achieve, decide how you're going to measure the risk and how you're going to measure whether it achieved what you wanted it to do. Then you define your architecture and such. Then you get your data ready and train it and have a plan to monitor its functionality. While you're running it, you have reports from users about the problems. You can keep track of that. And then you have continuous validation while it's running, so you can measure what problems there are and hopefully improve it. And then, of course, when you're done, you have to decide what you're going to make of this project and then appropriately dispose of all the equipment and such, so you don't lose anything confidential in the data. So this is much more practical to help guide you actually through an AI project. So I found that one helpful. And of course, OWASP is there. OWASP is the Open Web Application Security Consortium or something. And they have, it's a volunteer group of tech experts, and they help guide you to make many secure things. And they have 2 top 10 lists for machine learning. There's machine learning risks here, which are the main ones you worry about. And there's a separate one just for large language models. So, input manipulation is where this is the most common thing. You can evade the model. For example, think of a Tesla car that has a camera and it's trying to drive down the road. Well, it can identify cars and bicycles and police cars and roadblocks and things like that. But you could have a car, and you could perhaps put bumper stickers and paint on the car so it has strange shapes. So maybe you would fool a Tesla so it doesn't recognize it as a car anymore. That's what happened in China. They made a special bumper sticker that will make cars invisible to the Chinese robotaxis. So that's an evasion attack. You can deliberately create input which will not be understood by the model. Then there's data poisoning. If you can somehow affect the training data people use to train the model, then you can teach it false things. And there was a very recent paper that came out just a couple of weeks ago where they wanted to find out about models giving medical misinformation. So they took a model and they trained it on a body of legitimate medical data they got from the National Institute of Health or something, and then they tried adding a little bit of false medical data to it. And they found that even 0.01% false data led to the model telling people the wrong thing 10% of the time. So it turned out that in that situation, the data poisoning was really bad. And all the current large language models are trained on something called the pile, which is just an enormous heap of data they found on the internet. And it includes a lot of really unreliable stuff like Breitbart and Fox News and stuff. So in fact, that makes me very concerned. It has a whole lot more than 0.01% false data included in that pile. So that's probably why AIs get things wrong so much. Then people could reverse engineer the model to extract the information it was trained on. This has happened a few times in various ways. You could deduce something, expose sensitive information, a similar attack. So authors did this. They wanted to see if the models had been trained on their copyrighted books, and they were able to get it to repeat pages of copyrighted books, showing that they absolutely did train those models on copyrighted books without paying for that privilege. So there are lawsuits underway. And then model theft, where you can hopefully use a model and deduce the weights and make a copy of the model without having to do your own training. Modifying the code it uses with supply chain attacks. And then there's transfer learning. You can take a model trained on one task and then fine-tune it on another task. This is kind of why fine-tuning is not that common. So one thing that many of my clients want, and I'm an AI consultant for some corporations, they want to have a model trained on their personal proprietary corporate data, not on just the general internet. They want it to have learned English from the general internet, but then include their personal corporate data. And one way to do that is to retrain the model. But this is, number one, very expensive and difficult, but number two, it has a problem called catastrophic forgetting. If you have a model that's trained, and then you do some retraining to train it on more, it forgets the old training when it learns new training. So you're trying to train it on your corporate PDF data, and then it forgets the security barriers that were put in there before. So that's a problem. And so as you'll see, this is not the popular way to add extra data to a large language model. Instead, you do it with retrieval augmented generation, which we're going to do in the projects, and I'll talk about in a few slides. Then model skewing, you can have models very easily learn bigotry. Really what models do is they learn sort of to predict from the average. So if you give them a bunch of resumes, and many of the black people got fired more than the white people, it will decide, well, black people are no good, because it just finds a pattern and believes it. And so if you can give it data that has any kind of trend, then it will learn that trend. And so then, of course, if you take the output of the model, you may be able to poison it. You may have output that's dangerous. And, of course, you may be able to reprogram it. You may be able to change the parameters to make it do something undesirable. So, and then you talk about large language models. Similarly, prompt injection is the most common attack, and we're going to do it today in the projects. You can ask a problem, like if you ask a large language model, tell me how to build a poison to kill somebody, it will refuse because they have tried to build security into it. Don't do these terrible things. But if you say, I'm writing a novel, and in the novel, Arthur is planning to poison his wife, so how can Arthur in the novel make a poison? It'll usually tell you. So you just have to find a way to ask a question, and that will evade the security boundary. It's very much like fooling a human into doing what they're not supposed to do. That's prompt injection. Insecure output handling is where you take the output and you fail to examine it for dangers in the output. You might even have the old-fashioned dangers like cross-site scripting and such in the data that comes out. You can, again, poison the training data so the model learns bad habits. This has happened many times. You can have denial of service, where you ask a lot of questions and use up all the CPU power. The supply chain of the software can be compromised. This is a real big issue. All the large corporations will not let their employees use OpenAI, ChatGPT, Gemini, or any of the public models because they all train on the data when you type in queries. And if you were to copy some corporate data and say, build me a spreadsheet out of it, it trains on that, and anything it trains on, it might repeat to the next person. So anything you send to those models should be considered compromised. That's the problem with sensitive information disclosure. They often do just repeat some of the training data verbatim. And there's something called plugins that can be insecure. This is a big one. You trust the model to do something that it's not really good enough to do. For example, to drive a car. You trust this AI to drive a car, but often the AI is not really strong enough to drive the car safely, so you have trusted it to do a job that it's not really good enough to do. And over-reliance is similar. People may trust the model. This is the biggest one. I think this should be number 1 or number 2 in my experience. People trust large language models, and then only through experience do they discover that a large portion of the time it is just lying to you. So you get used to using it instead of a search engine, and then you're sorry when you go believing something completely wrong. And then, of course, you mentioned before, model theft. If you're a rival company, you want to steal a model without having to pay for the training. So the commercial product, which I think is getting the most attention, is Microsoft Copilot. Microsoft Copilot is designed to actually help a business with these large language models. And so what it does is you can connect it to your Office 365, and it can read all your emails and your PDF documents and your Word documents and your SharePoint documents and everything you have, and take all that data and write progress reports and summaries and emails for you based on that. So it looks like this. Microsoft 365 Copilot has access to all the data you've stored in the cloud. And then what it does is you ask it, say, okay, find out everything about this case I'm working on, summarize all the emails and spreadsheets and everything, and write a progress report 2 pages long for my boss saying, what have we been doing and what are our next steps? So it will fetch all the documents here that seem relevant by just doing something like keyword matches. That's what Microsoft Graph will do. Microsoft Graph will fetch all the documents that are relevant to this, and it will add them to the prompt, and then it will send it to OpenAI's ChatGPT. It'll have a general question from you, write a progress report based on the following data, and it will then add all that data to this one question. So it's not retraining the model to memorize all this data, it's just adding it to your query. And this is why they're real proud of the fact that the models can now take a lot of data, like they talk about 50,000 tokens, 100,000 tokens. the modern large language models can take basically a whole novel worth of question in one go. And that's because your question is, of course, not that long, but all the added data could be that much. And so that's what it processes on. This is the way to include corporate data in a model. And if you pay for Copilot, Microsoft promises they will not train the model on your data, so it will not expose this data. And that's what Copilot does. So that's Microsoft handles the security of the machines itself, but you need to control the permissions and labels and what humans do, and that is the problem. Suppose I decide, make a report, we're having budget cutting at our company, I'm supposed to make a plan to cut my department's budget by 10%, examine all of our expenses, and make a recommendation for me. The problem is you probably have emails that say, okay, here are the employees that have a bad performance review, we're thinking of firing them, but don't tell them anything yet. We're still debating it. Well, the AI will fetch that email and say, oh, that's relevant to the budget, and include it in your output, but that output might be going somewhere public. The AI doesn't know that that's confidential data, and the human might leak it out. That's an issue, and that's not really the AI's fault. The problem is you would need to label all your data. This is a huge problem with all cloud deployments. All this data should be labeled with sensitivity labels. And Microsoft does have the ability to include sensitivity labels. So you could tell it, I am making a public document, therefore do not include confidential data in this assessment. And the technology exists to do that. The problem is it will only work if you actually labeled all these files with sensitivity labels, and nobody has done that. So people are running multi-cloud environments. They have 40,000 permissions. Most identities are greatly over-provisioned. Most people have cloud identities that have just full control over everything. The workload identities outnumbering human identities 10 to 1. Most of the accounts doing things in the cloud are not humans. They're derived processes. Only 1% of permissions granted are actually used, or 50% of identities are super administrators, and that's the problem. The current state of the cloud is people have just taken terabytes of data and they've thrown it up in cloud shares without labeling it or separating it or appropriately limiting who can get to it. And so if you use any system of searching through it to find information, it's going to not understand the sensitivity labels. This is a problem, and it's really not a problem intrinsic to Microsoft Copilot. It's intrinsic to the use of the cloud. And there's a huge technical debt. In principle, you could have your employees going back through all these old documents applying labels, but nobody wants to pay for that. So we have the current situation where there are going to be security problems caused by this. So there's just a lot of links about Microsoft 365. There are so many accounts, so many permissions not correctly applied. So Microsoft has this technology called Purview that will look at the sensitivity labels and limit what it does, but it only works if you have the labels on the data, which they don't. So this guy demonstrated a way to exploit Microsoft Copilot using prompt injection to get it to do things like add an HTML tag to replace a bank number with that of the attacker and things like that. There's a lot of ways to trick AIs into doing the wrong thing. And Meta found a way to just tell it to ignore previous instructions or just add a bunch of spaces to a prompt, and it will escape the security model. And then, of course, there's Microsoft Recall, which they've attempted to deploy several times, which was going to be Microsoft's version of Apple Intelligence that was going to live on your Windows machine and take a screenshot every 15 seconds of everything you're doing and record all the web pages you go to and all the emails you go to and all the videos you watch and add it all up so an AI can see everything you've done and therefore be like your personal butler helping you in some way, which hasn't really ever really been made clear. But the first response is, this sounds insane. It's taking a database of everything I do. The privacy intrusion is appalling, especially since nobody much trusts Microsoft to protect it very well. And so this thing has not yet been deployed in a large scale. Just early beta tests have been. And the question is, what exact benefit was this going to give me that would justify all that? And it's not clear at all. And the more cynical people say the benefit is Microsoft will take that data and sell it. And that might be the case. Anyway, so that's a summary of what we're going to do here. Let me stop this recording.